Okay, welcome to video number 6, which will go over the last set of games in the back of your packet. The games are called, a game or activity is called a Loopster puzzle. And a Loopster puzzle basically looks like this. But before I explain this, what I'm going to do is jump back and show you the logic behind one of these puzzles. It's basically based off of a similar concept to Sudoku puzzles. The thing with Sudoku puzzles, if you're familiar with them, is that they really are not, even though they use numbers, they're not really mathematical. They're really logic puzzles. So let me show you how they work. Let's say that this is a 1, 2, 3 puzzle. You start off, you have 9 circles, and a 1, 2, 3 puzzle would work like this. You need a 1, a 2, a 3 in this row, a 1, 2, 3 in this row, and a 1, 2, 3 in this row. But you also need a 1, 2, 3 in each column. So you can use logic if we begin the puzzle, and let's say that you're given this is a 1 and this is a 2. If someone tells you that this top center one is a 1 and this one here is a 2, you can, by logic, you can figure out all the other circles. For example, this circle right here, can it be a 1? No, because there's already a 1 in the top row. Can it be a 2? No, because there's already a 2 in the last column. So this one, by process of elimination, has to be 3. If this one's 3 and this one's 2, this guy down here, he's got to be 1. If this one's 3 and this is 1, this one, by process of elimination, it's got to be 2. Now, look to the center box. Look up and down. Can it be a 1? No, I already have a 1 up here. Can it be a 2? No, I already have a 2 over here. So this guy's got to be a 3. If this is 2 and this is 3, what am I missing? A 1. If this is a 1 and this is a 3, what's missing here? This has got to be a 2. If this is a 2 and this is a 1, this has got to be a 3. Now, what's cool about them is that it's not always going to be 1, 2, 3 pattern. It could be other things. So I'm going to do one more. Forgive me if you already understand. I just want to make it easy for people. So here we go. This puzzle is going to be a 2, 5, 9 puzzle. Why? Because I said so. Okay, so that means you need a 2, 5, 9 in every row and a 2, 5, 9 in every column. And let's say that I tell you this guy is 2 and this guy is 5. Now, if I look up here to this left circle, can it be a 2? Looking up and down? No, because I already have a 2 in the first column. Can this one be a 5? No, because I already have a 5 in that row. So I'm going to fill in my 9 here. If this is 9 and this is 2, this one has to be a 5. This is a 9 and this is a 5. This has got to be a 2. Look to my center circle. Can it be a 5? Looking up and down? No. Can it be a 2? Looking up sideways? No. So this one's got to be 9. If this is 2, this is 9. This guy has to be 5. If this is 2 and this is 5, this one's got to be a 9. And if this side's 9 and this side's 5, by process of elimination, this one's got to be a 2. Now, that's what a Sudoku puzzle does. And you can see that while it uses numbers, it doesn't really use any math facts. It's not adding or subtracting or anything like that. So this is called a Loopster puzzle. It has the same 9 circles, 3 rows of 3 circles, but you notice that there are these gray bands around the circles. And what that tells you is that the band tells you, if you look down here, that we're going to be doing multiplication only, that if you multiply these 2 circles, you get the answer in between. So these 2 multiply to make 5. These 2 multiply to make 10. These 2 multiply to make 10, and these 2 multiply to make 2. Now, the only numbers you can use in this Loopster puzzle are 5s, 1s, and 2s. That means I need a 5, a 1, a 2 in every row, a 5, a 1, a 2 in every column. So let's look up here. Looking at my 10, using the numbers 5, 1, and 2, and I can only use multiplication, what numbers do we know it's going to be? Well, you know it's going to be 2 and 5. But you don't know if it's 2 on top and 5 on bottom, or 5 on top and 2 on bottom. So what I like to do is put a little 2 over here and a little 5 over here. I call these baby numbers. It means I don't know which way they go, but it's definitely either 2, 5 or 5, 2. Here's what's cool. In my first column, I need a 5, a 1, and a 2. With these two circles, I've used up my 5 and my 2, so that means this guy has to be the 1. Now, looking over to here, what two numbers make 10? Well, that's got to be 2 and 5, but I don't know which way, so let's put a baby 2 and a baby 5. Looking at this one, what two numbers out of these three are going to make 2? Well, you know it's going to have to be 1 times 2. But look in your bottom row. You already have a 1 down here, so this guy can't be 1. This has to be a 2. Means this one's a 1. Now I can go back to this one. I know that my bottom circle now, it can't be a 1 and it can't be a 2, so it's going to have to be that 5 that we were not sure, that our baby number. If that's a 5, this has got to be a 2. Now, looking in my last column, I've used up my 2, my 1. So I don't even have to know any math. By logic, I know if this is 2 and this is 1, this one's got to be 5. Here's my question. 5 times what number gives me 5? 5 times, 1. So now in my top row, I've used up my 5 and my 1. This can't be a 1 or a 5. This one's got to be a 2. See, remember in the beginning, we didn't know whether the 2 went on top or on bottom, but now that we've worked our way around the puzzle, we can tell that the 2 went on top and the 5 went on bottom. And there's only one way. The only answers that work are 2, 1, 5 in the top row, 5, 2, 1 in the second row, and 1, 5, 2 in the third row. Now, these puzzles become fun for almost every student at some point. That point is when they really know their facts, when they have them mastered. So this is kind of an enrichment activity at the beginning. In the beginning, this will be used with students that have caught on and are doing well. I will show you a few more puzzles. If this seems difficult to you at all, please watch at least 2 more puzzles, and by that point, I'm confident that you'll say, oh, this is easy. Okay, it just takes a couple puzzles to see. So here's a new one. Instead of doing 5, 1, 2, this time we're doing 5, 3, 4, which means I'm going to be doing the numbers 5, 3, and 4. I need a 5, 3, 4 in every row, a 5, 3, 4 in every column. So we start again, and of course this is multiplication only. We come over here. What two numbers are going to make 20? Well, obviously it's the 5 and the 4, and we don't know which way they go, so we're just going to put a 5 here and a 4 here. Okay? If this is 5 and 4, what number is missing in our first column? Well, it's got to be the 3. Now we move over to the 12. What two numbers make 12? 3 times 4, but we know the 3 can't go in the bottom row because we already have a 3. So put in your 4 here and your 3 there. Bottom row, you know you need a 5, 4, 3 in every 3, 4, 5 in every row, and we already have the 3 and the 4, so this guy has to be 5. Now, 5 times this one makes 20. So what's this one have to be? It's got to be our 4. If this is 5 and 4, what number have we not used in our last column? It's got to be the 3. 3 times what number gives us 15? That's got to be the 5. Now remember in the beginning we didn't know what went on top, the 5 or the 4? Well, now we do know because we have a 3 and a 5 up there. This one's got to be the 4, and this one's got to be the 5. Okay, hopefully that one was a little easier, but let's try another one. This is the next puzzle. It's a 5, 6, 7. So you need a 5, a 6, a 7 in every row, 5, 6, 7 in every column. And let's come over here. What two numbers make 35 out of 5, 6, 7? It's going to be our 5 and our 7. And what have we not used in our first column? That's got to be the 6. Then we come along here. What makes 35? 5 and 7, but we don't know which way they go. Let's come over here to my 42. That's got to be 6 times 7. And the reason we know that we already have a 6 down here, so this guy's got to be the 7. 7 times 6. That helps us to come back here now. We need 5 and 7 in these two circles, but now we have a 7 in the bottom row, so this has got to be the 5. This has got to be the 7. In this last row, last column, we have a 7 and a 6, so this is the missing number is 5. 5 times what is 30? That's got to be 6. Now, going back to our beginning, we don't know which way we didn't know whether it was the 5 or the 7 on top, but now I can tell because I have a 5 and a 6 up there. Here's my 7, and there's my 5. Now, someone might ask, do I always have to go in that same order? No, you don't. So let's try it in a different way. Let's get rid of all of this. Go away. Let's say that I started the puzzle. Let me grab a pen back out. Pen. Let's go to blue. Okay, now let's say that I started here. What makes 30? Well, we know it's 5 times 6, but we don't know which way it goes. But check this out. If you look sideways, out of the 5, 6, 7, I've already going to be using a 5 and a 6. So this guy's got to be the 7. 7 times what? 7 times 5 is 35. Now what's missing in our first column? Well, I need my 6. Now I move along. I got 35. So that's going to be 5 times 7. Now, can this one be a 5? Well, let's look sideways. No, it can't be a 5. So that's got to be the 7. That's got to be the 5. In my bottom row, I've used my 6 and a 5. So this has got to be my 7. 7 times 6, 42. Up here, it's 5 and 6. But in my last column, I've already used up my 7 and 6. So that's got to be the 5. And that's got to be a 6. Now, there's for every times table there are 4 of these puzzles. There's like a 5 1 2, a 5 3 4, a 5 6 7, and a 5 8 9. When you get to the 2 times table, there's a 2 1 3, 2 4 5, 2 6 7, 2 8 9. It helps the students practice only a couple facts at a time. If you've noticed in this black box over here, since we're working on the 5 times table, the only problems we'll be able to create in this is 5 times 6, 30, 5 times 7, 35, which we'll be working on. They might not know 6 times 7. We might not have learned that one yet. So anyone that I don't think the kids knew, I put that in the note box on the side here. So if they don't know what 6 times 7 is, they'll be able to look over there and it will give it away to them. And these Loopster puzzles, again, will become fun eventually for all kids. But if they are still struggling with knowing their facts, this game would be anything but fun. These activities, the Loopsters, go with those other games, the Seeksters and the Do Nows, and those are activities that if the class is not ready to move on after week 1 and you need to do a second week, these are a whole bunch of activities that the students who have mastered their facts could be playing while the other students are still playing the original 5 games from week 1 because they still haven't mastered their facts. That's the idea. I try to give you things to keep the kids that need supplementary help. They have activities to continually do, and then there's enrichment activities for the other students, and they'll be able to do that so that you're free to bounce back and forth and work with either group as you see fit. Okay, thank you.